Hello everyone, this is Adish. I'm a grade 10 student from Mumbai. So today's problem is chef and lottery. The difficulty level of this problem is easy because you only need to know arrays and loops in order to understand my solution. So in this problem we are basically given an array of size n, and in this array we need to find out how many pairs which we can perform such that the elements in the pairs are equal. So we need to divide the n integers into some number of pairs, into the maximum number of pairs actually, and the condition which must be satisfied for two numbers to be in the same pair are that the number should be equal. So we need to answer this for t independent test cases, and since the value of n is up to 100 and t is also up to 100, an n square solution or even an n cube solution will easily pass in 1 second. So let's consider an example. By the way, the solution which I described will be O of n, and at most O of n log n actually, and that's why it will easily pass within 1 second. So let's take the first example where we have these four elements 21, 13, 17, 13. Then in this case it's clear that 13 and 13 will go in one pair, and we only need to print one team. 17 and 21 cannot go into another pair, so the answer would be 1. In the next example, 5 and 5 will go into one team, 7 will not go into any team, the remaining 5 will not go into any team, and 11 and 11 will go into one team. That's why the answer would be 2. In the next example, 2 and 2 will be in one team, then 17 will not go into any team, 2 will not go into any team, 19 will not go into any team, 23 can go into this team with another 23. So far we have kept two teams. Then 52 will not go into any team, 37 will go into a third team over here, and that's why you can verify that another 23 and 23 will happen. That's why there will be four pairs of teams, and the formal explanation is over here. So these are the ticket numbers, these are the 13 ticket numbers, and there are two ticket numbers which contain the number 2. That's why that forms one pair. There is two ticket numbers with 37, so that forms one pair, and there are two unique pairs of 23 because there are a total of 4 23s, so that's why there are two pairs of 23s, and in total 2 plus 1 plus 1 will give you 4, so there are 4 teams which you can form. And in general the key idea is that there are two possible solutions. So one way to approach the problem would be to use a frequency array. So if you let f of I equal to the number of occurrences of I in the array A, and this basically means the number of indices j such that A of j is equal to I, or basically the number of occurrences of I in array A, that if we represent frequency of I to be f of I in this new array, we need to use a memory of size up to 100 to show the frequency array. And then the basic idea is that for each pair, if we let f of I be the number of occurrences, then if you take f of I by 2 and if you floor it down, this will be the number of pairs with elements equal to f of I, or it's basically the number of pairs I comma I, and f of I by 2, basically that will represent the number of pairs I comma I, and this will represent the number of teams which you can form using the elements equal to I, and that's why the sum of f of I over 2 for all I going from 1 to 100, or from 0 to 100 basically, will be the total number of teams which you can form, and that will be the answer. And in an example you will realize that if you have 3 occurrences of 5, if you divide 3 by 2 you get 1, and that's why the answer is 1, like the number of occurrences with 5 is 1. And similarly for 11 it's 2, so 2 by 2 will be 1, and 1 plus 1 is 2. And similarly for the third example where you have 4 pairs of 23, 23 occurs 4 times, so f of 23 will be 4, 4 by 2 is 2, so 23 will contribute 2 to the answer. Similarly 2 will contribute 1 to the answer, and the other number which is 37 will contribute 1 to the answer because it appears twice, and all the other numbers which appear once will contribute 1 by 2, which is 0 times to the answer, and that's why we are summing up 0 along with 4 to get the sum of 4, and this is the basic solution with the frequency array. However, there is another solution which uses sorting, and that's a greedy solution. So the basic idea is that you can sort the array in increasing order. So for example, if you had the array 13, 13, 17 and 23 sorted in increasing order, then the key idea is that if you compare an element to the next element, and if these two elements are equal, then they form one team, otherwise they will not be any team. And you just increase the index, you just iterate through the whole array and keep track of how many such pairs there are, and you keep increasing the index by 1. You jump 2 positions basically when you encounter that I and I plus 1 are equal. So if I and I plus 1 are equal, you jump to I plus 2 instead of going to I plus 1. Otherwise, you go from I plus 1 to I plus 2 directly. Like if you are at index I, you go to I plus 1 if I is not equal to I plus 1. And if I is equal to I plus 1, then you go to I plus 2 directly. And in this way, you can efficiently in O of n, after an O of n log n sorting, find out what is the number of teams. And I'll just show you the code for the second approach. So in the C++ code, I taken the value of t, which is the number of test cases. For each test case, I taken the array and I sort the array in increasing order. Then I perform the loop of going for all elements from 1 to n minus 1. I choose n minus 1 because if it's n, then n plus 1 does not exist because n is the last index. So for all I going from 1 to n minus 1, if ai is equal to ai plus 1, we increase the answer by 1. And we also skip to the second index from the current index. And in this way, if we don't increase I by 1, then we know that we are simply going to the next index. And if we increase I by 1, we are going to increment I twice to skip the next index. And in this way, we can effectively maintain the number of pairs of indices which are equal, and we'll just print that answer. For the Python code, which uses a set or a map data structure, or basically a frequency array kind of thing, for each test case, they take in the value of the array from the input, and they store all the elements in a set, and they increase the answer by the frequency of an element in the set and integer division by 2. This basically takes the floor of the frequency by 2 and it increases that to the final answer, and in the end you print the answer. And you can verify that this is exactly the same thing as finding the sum of all occurrences and dividing it by 2 for each number. And when we divide by 2, we take the integer division, which is the floor operation. And as you can see, both the codes gets accepted. So I hope you like this problem and my solution.